Hey, 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 what's up, everybody? It's your boy Hydrogen Harry back again for another round of some amazing science that you guys are sure to enjoy. So first, before we want to start, I want to thank our partners in this and prime time of Palm Beach County. We thank you guys for your support in this. Hopefully you guys enjoy this awesome videos. Also, a big shout out to all of our viewers at home. Without you guys, we wouldn't have an audience to perform for, and we've got some really awesome stuff in store for you guys today. Now, we also have some really cool stuff that you guys can do at home if you check out the link in this video, as well as on our website, sfsciencecenter.org. We have all these awesome stay-at-home STEM activities that you guys can try at home, and this one is actually really cool. This is what we're going to be demonstrating today. It's our Differing Densities Lab. So if you want a more in-depth view of all the things that we're going to be doing today, go ahead and click that link, and you can actually download this form here to follow along at home. Now, again, what we're going to be doing today is talking all about something called density. Now, if you've never heard of density, it's a very important property that we have in science. Density talks about two things: mass and volume. Right? The mass is basically how much of something there is, or how many molecules are in that particular object, and volume is basically how much space that object is going to occupy. And these two things together are what we use to figure out density. It's basically how much mass do we have for a given volume, right? So D equals M over V, or density equals mass over volume. Now, what that actually means is basically how much molecules can we pack into a particular amount of space. And we can actually very easily demonstrate that with a few different experiments that we're going to be doing today. Now, to understand a lot of these experiments, we also have to understand our states of matter. And if you've seen any of the Nitromaniac shows that we've had in the past, we've definitely talked about our states of matter, particularly with our Nitromania show. That's where we get our name. Now, in that show, we talked about three of our main states of matter: a solid, a liquid, and a dance. And we had a really cool dance that we did with it. I'm going to do this dance for you guys. All right, first we're going to talk about solids. Solids are really compact and kind of really packed in together. Then we go on to our liquid. Right? Liquids have our molecules a little bit further apart, and they can kind of flow back and forth and slide across one another. And then we have our gases, and those molecules are super spread out, and those really, really far apart, and that's why most of our gases are going to be invisible, just because those molecules are so far apart. Now, those three states of matter play a big role into figuring out density. Right? Usually you'd think that the more solid an object is, or the more molecules are packed into an area, that is actually going to have a higher density. But with a lot of these experiments today, we're going to show you just the opposite. So with our first experiment, let's go ahead and do a simple float test. All right, and this actually helps us test density very easily. So I've got just a giant thing of water right here. We're going to go ahead and test to see the density of this water. Now, this water has a particular liquid density. We say it has a liquid density of 1. And anything that's more dense than that, what should happen? The object should sink. Anything that's less dense than this water, that object should float. All right, so we have a couple of very simple objects here. We have a rock that I went outside and found, and then we had a piece of aluminum foil that I mushed into a ball and tried to get it about the same size and shape as our rock here. Now, since both of these things are pretty much the same size, that means they're occupying the same amount of space. These two things have a very similar volume, right? They're occupying the same amount of space. But one of them is going to have a lot more mass, and that's going to be our rock. Right? Even though they're occupying the same amount of space, there's many more molecules in this rock than there are in this ball of aluminum foil. And when we do this simple test, we can show that. Right? When we drop our rock into our water, that rock sinks down to the bottom pretty quickly. Right? And that's because it's going to be much more dense than water. Instead, when we take our aluminum foil and we drop it in there, you'll see that our ball of aluminum foil floats, right? So even though they have the same volume, the mass difference between these two is going to determine how dense it is. Since we have more mass in this given volume, it's going to have a much higher density. It's going to sink to the bottom. This aluminum foil has less mass in that given volume. It's going to have less density, so much so that it's less dense than water, and it's going to float, right? So that's one easy way we can actually test the density of some of our different states of matter. Now with solids, it's pretty easy because you can just kind of drop stuff in water, since we know how dense water is, and you can test to see what sinks and floats, and that's how you can determine which one's more dense and which one's less dense. But what if you wanted to test the density of liquids, right? Just like our water, all types of liquids are going to have different amounts of density. And how do we actually test to see what's going to be more dense and what's going to be less dense? Well, in order to do that, we can actually create something really cool called a density tube or a density column. All right, we can find some different liquids with different densities. We can actually stack those things on top of each other, and it actually ends up looking pretty cool. Now, before we get to that, I want to make sure there's one thing that people don't get mistaken. A lot of people mistake mass for weight. And that's going to be very different, right? Because weight is not determined by how much of something there is, but it's actually based on how much gravity is pulling down on something. Like if I were to take myself and measure my weight here on Earth, right, I'd weigh about 185 pounds. But if I were to go up in space onto the moon, there's much less gravity up there in space. That difference in gravity is actually going to change my weight. If I were standing on the moon, I would weigh much less than I do here on Earth. And that's why you see astronauts kind of doing that super cool spacewalk when they're kind of bouncing around each other. Now, even though the weight is different on those different areas in space, the mass is going to remain the same. Even though if I'm here or if I'm up on the moon, my mass has not changed. Mass is not based on the gravity, right? So mass and weight are a little bit different. Just wanted to make sure we got that in there. All right, now it's time for our density tube. So to do this, I'm just going to grab my beaker here, and I'm going to grab some different liquids that I have. Those different liquids, again, are going to have some different densities. To make this work, you want to make sure you have the most dense liquids down on the bottom. All right, so I'm going to start with something that a lot of people definitely have at home, just some honey. Right? If you've ever poured out honey, you know that it's much thicker and much more kind of soupy and drippy and globby, a lot different than water, right, which is really runny and kind of moves very fast. Right? This is going to be something called viscosity, or how viscous a liquid is. Right? The more viscous it is, the faster it's going to move. So this stuff right here, you can see, kind of drips down, very globby. Right? Doesn't really run all over the place. It's very thick. Right? So we're going to get a nice layer of honey there. All right. So a nice layer of honey down on the bottom. All right. Now this honey is going to act as our base layer. All right. Now we're going to go ahead and stack some different liquids on this. And the next liquid I'm going to need is my milk. All right. Now I'm going to go ahead and grab that milk from the fridge just so that we can stack these things. But before we do that, before you start stacking any of those things, you need to be very careful about how we're actually going to layer them. If we just start dropping all those liquids into this container, just dumping it in very kind of recklessly, a lot of that stuff might end up mixing. Now, we don't want that to happen. We want it to layer very carefully on top of each other. So if you're at home, you can actually use a different like syringe or pipette, or this really cool method I'm going to show you guys with a spoon. Right? The spoon is going to help us kind of slow down how we're going to be filling out our different liquids. Right? So I've got some whole milk here. We're going to go ahead and just pour that in. But again, we don't want it to splash very much. So I'm going to take my spoon upside down. I'm going to put it inside my container just above where the layer of honey is, and I'm going to gently pour it over the back of that spoon. Right? That's going to really slow down that liquid and make sure I get a nice layer that's going to form on top of my honey rather than splashing down and mixing with my honey. All right, so we've got a nice layer of whole milk there. Let's go ahead and show you guys, make sure you guys can see exactly what's going on with this density tube, right? If you look very carefully, right, you can see I've got those two layers stacked on each other very neatly, right? We've got our base layer of honey, and then we've got our whole milk here. Next, we're going to add something that is a little bit lighter, a little bit less dense than whole milk, and dish soap is actually just slightly less dense than milk. All right, so the same thing applies here. We want to make sure we drip our dish soap right onto the back of that spoon, just so that we get a nice layer forming right on top of our milk. Now, I know this may take a little bit of time, but patience is key. You definitely don't want to, again, go splashing around or putting too much on there, because if you get too much, then you're not going to actually get these nice clean layers. Instead, you're just going to get some things that are kind of splashing into each other and all mixed up, and it's not going to look nearly as cool. All right, so we get a nice layer. All right, we get a nice layer here. All right, so our dish soap is pretty much done there. It's not quite as thick of a layer. Let's see if I can quickly squeeze out a little bit more, add a little bit more force there. There we go. All right, a nice layer of dish soap there, right? So you can kind of see that layering up right there, a nice 3 layers. Now this next part is, again, where it gets really tricky, because now we're getting into things that are a lot less viscous and a lot more runny. They move a lot faster. All right, so the next thing we're going to get is water. And here's where, again, it can get tricky. Usually if you're mixing soap and water, right, those things tend to mix very easily. So you want to be very, very careful with this next step as well. All right, so I've got my measuring cup of water right here. I put it in a measuring cup, that way it's a little bit easier for me to pour. I've also added a little bit of blue food coloring just so you can get a really nice look at the layers when I pour them out here. So go ahead and just very carefully add in, trying not to splash as much as you can. Might get a little bit of splashing there, but these layers do start to stay just a little bit. All right. All right, so we got a little bit of mixing in there. Not too bad, but that's all right. Just add a little bit more. Make that layer a little bit thicker. All right. And there you go. And you can still see there's still a little bit of those layers there, right? They haven't mixed too much. And that's why you want to make sure you're being very careful. Now, the last layer that we're going to do is going to be the least dense of all of these liquids, and that's going to be our vegetable oil that we have here. Now, if you've ever mixed oil and water, right, you might notice that those two things don't really mix very well, right? And that actually helps make some nice, neat layers here at the very top, right? Oil and water, they do not mix because they're polar densities, right? They're a lot less dense. So our oil should float very nicely onto our water here. All right. And just like that, we've got our density tube or a density column here, right? And you can see those different layers, right? We've got the oil on top, we've got the water, we've got the dish soap, we've got the milk, and we've got the honey, right? So really cool. Now you can do this with more types of liquid. You can start adding like lamp oil, which is a little bit lighter. You can add corn syrup near the bottom, which is a little bit heavier, right? There's lots of different things that you can actually add to this, but you want to make sure you're always adding it in that correct layer so you can look up online what the liquid density of all of those different liquids are, and you can test that out. Now we can take this experiment a bit further to, again, test some of the densities of some more solids that we have. So I have a couple of just common small household objects, and I want to see which layers do they sink to and which layers do they float to. Now I haven't actually tested this, so you're going to be learning along with me. We'll go ahead and start with our normal soda cap here, right? So if I just drop my soda cap in there, what you'll notice is that the soda cap actually falls beneath where the oil is and actually stops just above the water, right? So you can see that this bottle cap is actually a little bit more dense than our vegetable oil, but a little bit less dense than our water. So it actually stops right between those two layers. Now let's try with a wooden clothespin. Let's see where this is actually going to go. All right, and it looks like our clothespin did a very similar thing, right? It's definitely beneath that oil layer, but floating on top of that water layer. More dense than the oil, less dense than the water. All right, let's try something just a tad bit more dense. We've got a little screw here. Let's go ahead and drop that screw. All right, you guys at home, tell me where it fell to. Do you guys see it? If you look carefully, that screw fell all the way to the bottom. So you can see that screw, even though it's smaller than our soda cap and smaller than our clothespin, it's got a lot of density, right? It's more dense than those, and it's more dense than all of the different layers that we have here, so it falls all the way to the bottom of the honey. Now again, you can go ahead and try this at home with lots of different liquids and different layers, and drop some other different items in there to see if you can tell the densities of those different things. So we've tested the densities of some of our solids. We've tested the densities of some of our liquids. Now let's go ahead and test the densities of some of our gases. Now everyone at home, I want you to go do this with me. Everyone take a deep breath in and breathe out. What you guys are breathing in and breathing out is all of the air that we have around us in our atmosphere. Our atmosphere is made up of lots of different types of gases, right? Most of the gas that we have in there is actually nitrogen gas. The gas that we need inside of our lungs is the oxygen. And then there's also other gases like carbon dioxide and methane and ozone, all those different things that we have. Now, a lot of those gases, just like all of the liquids and solids that we've looked at here today, are going to have different densities. Now, it's really hard for us to actually see what's going on in the air because our gases are mostly invisible, but there is something that we can use to help us see our gases a little bit better. And that's going to be some balloons, right? So if you have any balloons lying around at home, you can definitely try this as well. Now, if I take any of my balloons and I fill it up, I'm just going to fill this one up with the air that's inside of my lungs. So it's going to get mostly like carbon dioxide inside of this balloon. All right, we've got our balloon filled right there. We'll go ahead and close this off. Always tough to do with gloves on, but do the best that I can. Here we go. All right, so we close off our balloon. All right, don't let any of that air seep out. All right, and now we've got our balloon filled with air. Now there's a couple different things that we can do with this balloon to test the density. All right, one thing to do would just be to take it and drop it. All right, now what happens to this balloon? All right, this balloon is going to fall down. All right, that's going to be because the combined mass of the gas that's in there and the mass of the balloon is going to be more dense than the air that's around us. Because it's more dense, instead of floating, it's going to sink, right? It's going to fall down to the ground because gravity is pulling it that way. But what if we had something that was less dense than the air around us? Right? Do you guys at home know of anything that might be less dense than water? Or less dense than the air? I'm sure you guys do. You see this all the time whenever you're doing birthday parties or you're at sporting events or you're having any sort of celebration. You might use something called helium. Right? So we have a little bit of helium here today, and we can actually use this helium very similarly to the balloon that we have. Right? So we'll open this thing up. We'll grab one of our balloons. A nice green one for the helium. All right, we'll go ahead and fill up this balloon with some helium. All right, so we have our balloon full of helium here. Again, tie this off. Now again, helium we think is less dense than the air around us. And when something is less dense than the air, instead of sinking, what should it do? It should float. And also get stuck on my face. Wow, it's pretty cool. Now this helium, again, less dense than air, it's going to float up. Don't want to lose it. So if we do our experiment where we're dropping our balloons, you can see one of them is going down, the other one's kind of either going up or down depending on how heavy the balloon actually is. Right? We've got to take that into account as well. Now, we know of things that are more dense, we know of things that are less dense. Very easy for us to see that. But the density can actually affect some other things that I know you guys might have tried in the past. Raise your hand or make a comment down in below if you've ever taken helium and you've taken that balloon and you've inhaled it. Right? Does anyone know what happens at home when you do that? Well, it's something that's pretty cool and pretty funny. We can also test how density is going to affect our voice if we do that. All right, so I'm going to just take my scissors here, cut a little hole in there, and take some of my helium.
And you can see, when I inhale the helium, my voice actually changes. It gets really high-pitched, right? It's really, really cool. That's because since this air is so much lighter than the air around us, it actually affects how our vocal cords are going to be vibrating, right? That vibration is affected since it's lighter. It's easier to vibrate. That high frequency of vibration is going to end up making my voice sound a lot more high-pitched. Now, eventually, my voice is going to return back to normal, and that's because I'm still breathing in and breathing out all the regular air in the atmosphere, and the helium is going to exit my system. Now, there's something else that we can do that's also equally as cool. Just like we have stuff that's less dense than air, I also have some really cool gases that are more dense than air. Right? This special gas that I'm going to be using today is something called sulfur hexafluoride.
Right, now this sulfur hexafluoride is a great demonstration of taking a gas that's going to be more dense than air. Right, so I'm going to go ahead and take one of my balloons and actually fill up my balloon with some sulfur hexafluoride. It does make a loud noise, so I apologize if it gets loud. All right, so we got our sulfur hexafluoride here. All right, it looks very similar to any of the other gases that we have, so we'll tie it up. Again, always the hardest part is doing this with my gloves on. There we go. But remember, safety first. All right, so we have our balloon here, right, roughly about the same size as this balloon. Right, and if we drop them from a high level here, you can see, whoa, one of those balloons drops way faster than our regular balloon. And that's going to be our balloon with our sulfur hexafluoride. This thing is way more dense than the other balloon, right? So since it's much more dense, it's going to fall at a much, much faster speed. Now again, we can also test this to see what happens with our voice when we have our sulfur hexafluoride. So just like our helium balloon, we'll go ahead, just take a tiny hole. Woo! Oh no! Pop the balloon. Sorry for that loud noise. That's all right. We've got plenty of extra balloons over here. All right, we'll go ahead and fill up our sulfur hexafluoride into our balloon once again. All right. This time, I just won't close it. All right. So again, we saw what happened with the helium when we took our sulfur hexafluoride and we inhaled it. Since it was less dense than the air around us, it made our voice really, really high pitched. Since this stuff is less or more dense than the air around us, that heavier density should do something different. I want you guys at home to go ahead and make a hypothesis. Go ahead in the comments down below. What do you think is going to happen when I inhale this stuff if it's more dense than air? Remember, helium is less dense, this stuff's more dense. Helium makes my voice high pitched. This stuff
should make my voice very low-pitched. You can see, instead of being a really high-pitched voice, it's actually a really low-pitched voice. Right? It's much more dense inside my lungs. My vocal cords are vibrating at a much slower rate, and that's going to make my voice sound much, much denser. But as I inhale and exhale, my voice should return back to normal. Now, this stuff, again, is really, really cool, really awesome effects, but it's definitely something you should not try at home. This stuff's pretty hard to get to at home, but even with helium, you want to make sure you do with parental supervision, right? So this stuff can be really dangerous, just like any of the experiments we do here on our channel. Make sure you have a parent or guardian, some adult in the room to make sure that you are being supervised, right? And you can see just like that, my voice has returned back to normal, right? Really cool stuff that we can do with our sulfur hexafluoride. But that's not all, right? Just like we were testing how things floated and sank inside of a liquid, we can actually test this to see how things float with a gas. All right, and to do that, we're going to go ahead and take our water that we had over here and do some really, really cool stuff with this. All right, I'm going to tie this off, save it for later. Now, just like we can make stuff float in a liquid, we can actually make stuff float in a gas too. So to do this, we're going to bring back our little thing of water here, and I've made over here just a really cool little aluminum foil boat. All right, now if you know anything about boats, boats can very easily float. Also, this aluminum foil, very easy to float on our water, so if I place it right on top, it can float there. What if I told you that we could make this exact same thing happen, instead of using water, using our sulfur hexafluoride, which again is more dense than air? Well, instead of just talking about it, let's go ahead and try it. So we're going to go ahead, empty out our water over here. Make sure we get that rock out of there too. All right, so now we've got our empty container. Now we're going to go ahead and actually fill this with some sulfur hexafluoride. Again, this stuff gets kind of loud, so make sure you guys cover your ears if you need to. All right, so plenty of that sulfur hexafluoride inside of that. And now we take our boat, and our boat should, oh no, I think it's because it's wet. It might not be floating very well. That's all right. We can go ahead and try this again. We'll do it with a dry container because I've got some extra containers over here. All right. As always, science is not perfect, so if it doesn't work, try and try again. So go ahead. All right. We'll try it again. We'll make our boat float.
And, man, that's always a bummer. But just like we always say with science, if it doesn't work, we'll go ahead and try it again later. But with that one, doesn't seem like it would work. We'll give it one more try at the end. I'll get a nice dry piece of aluminum foil to see if that works. But as always, we want to make sure that you guys are asking us questions. We love answering questions from the crowd. So if you have any of those questions, go ahead and drop them down in the comments below. I'm going to try one more time with a new piece of aluminum foil. But I want to see those questions that you guys have. All right, so go ahead and grab some fresh aluminum foil. Just need a small sheet for, that's not a good one, small sheet for our boat here. All right, make a nice little boat really quickly there. Not the best boat. I wouldn't want to go on a lake or anything with that, but it should work for our purposes. All right, so we'll try one more time with our sulfur hexafluoride. Anybody else's ears ringing? I don't know. All right, let's try it with our new boat, see if we get it to float. Oh, no, not again. That's all right. We don't need that boat. We don't need this stuff. Hopefully you guys enjoyed all the other really cool stuff that we had. You know, again, science is not perfect, but I want to hear from you guys at home. Again, we asked you guys for a few questions. Let's see any of those questions down in the comments below. I will try my best to answer any and all of them that you have. And as always, we love you guys. Yeah, any questions coming through?
So Megan has a question.
All right, hey Megan.
What is density, and is it how heavy something is? They're just not really understanding what density is.
Yeah, so density can be a little bit confusing, right? So density is very related to how much weight something has, but it is a little bit more scientific than that because it really takes into account the mass of an object, right? Just like we talked about before with our rock, right? A rock is not like the heaviest thing in the world, but it's pretty dense, right? We have a lot of molecules, right? The solid is made up of many, many tiny little particles called molecules. And there's a lot of molecules packed into this really small space, right? Since you're taking so many of those molecules and packing them into a small space, it makes it much, much heavier. Right? An easier way to think about it, let's say you have Legos at home and you decide to build just a normal cube. But one cube that you make is actually filled the entire way with Legos. So there's Legos covering the entire inside of that cube. And let's say you make another cube next to it that's the exact same size, but this time you're only building the walls of the cube and the top, but you leave everything on the inside hollow with no Legos in there. Which one's going to be more dense? Well, the more dense one is going to be the one with all the Legos filled on the inside. Even though those two things are taking up the same amount of space, one's filled with a lot more Legos and the other one isn't, right? So the more Legos, more dense. The one with less Legos, less dense, right? So hopefully that was an easy way to tell you guys the difference between kind of how density works.
Kate, which is 6 years old, why do you think the boat didn't float?
That is a good question, Kate. Thank you for that awesome question. Why do I think it didn't float? Well, I've tried this experiment many times before, and I have been able to make it float, but there's one thing that's different that I didn't have here at home that I left over in my science lab, and that's going to be a tube. Right? Usually, whenever you have these gas containers, there's usually a small little like valve or tube there, and that valve, it really helps to slow down the air as it comes out. Since I was just taking this stuff straight out of the container, there's a lot of pressure, right? And you guys are going to learn a lot about pressure next week with Bunsen Bernie. He's going to be talking all about air pressure and how pressure works. That pressure was moving so fast, it was actually probably pushing a lot of that air into my container and then right back out. Think about it if you turn on your sink at home. You might turn it on a little bit, and you only get a tiny stream of water, and it's pretty easy to fill up a cup of water. But if you turn it all the way up, right, you increase the amount of pressure, sometimes that pressure is so much that it might force the water in and right back out. And so I think that's what was happening with my gas. But again, that's just a theory. In order to test that, I can always set up some more experiments. So I'm excited to hopefully get a nice hose or valve and try that experiment again to see if I can maybe show you guys. So stay tuned to Facebook. We'll post a little video if we can get that one to work really well.
Is there any other gases that can change your voice if you inhale it?
Yeah.
Henry?
Henry. All right.
David.
Oh.
David, age 10.
David. All right, David, age 10. Thank you for that awesome question. Are there other gases that can change your voice like that? There are. One common one that we can use as a substitute for the sulfur hexafluoride is actually the gas called xenon. And even though it sounds like it starts with a Z, that one actually starts with an X, right? So you can find that on your periodic table. Xenon is often used as a substitute for this sulfur hexafluoride, but it's much, much more expensive, right? So we at the Science Center, we don't want to spend too much money on all of our production, so our sulfur hexafluoride does the trick. But just like our sulfur hexafluoride, that is more dense than the air, so when you inhale it, it kind of makes your voice do that, that weird thing again. All right? Thank you, David, for that question. Awesome.
Our friend Bunsen Bernie.
Hey, my guy, Bernie. I wonder how he's doing. Hopefully good, hopefully good. What does Bernie want to know from me today?
He wants to know if the helium that you use is flammable.
Is the helium I use flammable? Well, that's an awesome question, but instead of me just answering it, I want you guys to learn something very important. Whenever you're dealing with stuff like this, you always want to make sure you read everything on our container. Right? This container is going to have all sorts of different words in there, but the most important thing you're looking for are going to be those warning labels. Not everything we deal with is entirely safe, and that's why we always say to make sure you have parental supervision when you are using a lot of these things. Now, if I'm looking on here, you would want to look to see if something is flammable, right? It'll tell you right away if something is flammable. This definitely says you don't want to be near it. You make sure you keep it out of the hands of children, but you don't see any labels that say it's flammable. So right off the top of your head, you might think that it is safe. Now, this helium is not actually going to be flammable, so thankfully for me, I'm not going to blow up or anything. No fire in today's show, but look out for a future show. We're going to have some fire. But with any of the gases or any of the experiments that you do have, you always want to make sure you always read those warning labels, and always, always, always make sure you have parental supervision before any experiments. Myself, Hydrogen Harry, and Bunsen Bernie, we're trained professionals. We studied for a really long time, but I do miss having him around to kind of make sure I don't set myself on fire or blow anything up. So, Bernie, thanks for the question. I hope to see you soon, buddy. Stay safe.
So we have one more question.
All right.
It's by Leah.
Ah.
It's about the column that you have.
All right, our liquid density column, sure. What's the question about our column?
What else could they add from home to make the liquid density column if they would like to do it at home and make more layers?
Sure. So there's lots of different liquids that you have. Every single liquid is going to have a particular density. So in theory, you can actually use any of those liquids out there. But there are some really common ones that we tend to use for our column. Right? Honey is a very popular one, but there's also corn syrup, which is going to be a little bit less dense that you can actually layer on top of that. So if you wanted to add a layer of corn syrup, you could. Also, if you have any real 100% maple syrup, that's very different from a lot of like the store brands, but the 100% maple syrup is actually quite runny, so it's a lot less dense than our honey and our corn syrup. So you can actually stack that on top, right? But it's not quite, or it's a little bit heavier, a little bit more dense than our milk. So you can actually use maple syrup as well. Same thing if you wanted to add some layers to the top. If you add any rubbing alcohol is going to be slightly less dense than our vegetable oil here, so rubbing alcohol will actually float on top. Same thing if you have any lamp oil or kerosene. That's one of the lighter liquids that we have out there, and that will actually float on top of both our oil here and on top of that rubbing alcohol. So you really can expand this column with all sorts of different liquids. You can just look online and search what is the liquid density of all those different liquids, and then you make sure you put them in the order from the heaviest on the bottom to the least, or the most dense on the bottom to the least dense on top, right? So awesome experiment. If you guys do try that experiment at home, make sure you drop some pictures in the comments below, send them to us. We love to see all of those things. So once again, I'd like to thank everyone for sticking with this show. Hopefully you guys enjoyed all the really cool experiments. Another thank you to Primetime Palm Beach County for being a good supporter of the show. We love you guys there and hope you guys enjoy the content. And as always, we love our viewers. Keep the questions coming. Make sure you're always staying home, staying safe, staying active, and keeping that mind always working. We'll see you guys in a couple weeks.